Okay, so what I wanted to do is go over a couple of the problems that we looked at from 8.1, specifically looking at like these altitude and applying these geometric mean problems. So the situation that we're looking at always looks like this. So I've labeled the stuff that we did this in our notes, but we have this right triangle, we have an altitude that's dropped, and that splits the hypotenuse of this big triangle into two pieces, and we call them piece 1 or piece 2 or base 1 and base 2. And then these legs that went along with that corresponded to these positions. So leg 1 and piece 1 and leg 2 and piece 2. So these things touch each other. And that would be the whole hypotenuse. And what we found was that the altitude was the square root, the geometric mean between the two pieces of my hypotenuse, or base 1 or base 2, whatever you want to call them. And my leg was the geometric mean between my hypotenuse and the piece that it touches, or the base that it touches. Okay, so if we're actually applying this in a couple different problems, again, the altitude is the geometric mean between my two bases, or my two pieces. I'm going to interchange those, base 1 and base 2, or piece 1 and piece 2. The leg is the geometric mean between my hypotenuse and the piece that it touches. Okay? So for this one, we have to ask ourselves every time, really, what kind of things are we solving for? Are we solving for a base? Are we solving for an altitude? Or are we solving for a leg? And this problem, our altitude here, we actually don't have any number there or any variable, so we're not going to use this formula at all. We're just going to focus on this leg one. So let's start with x. X is a leg. So we would plug in our hypotenuse of our big triangle, which would be 12 if we add them together, times the piece that it touches, and x touches 3, so we plug that in. And then we solve that, so we get the square root of 36, which we know is 6. Okay? And then if we were solving for the other leg, again we would use the hypotenuse, 12, and we would use the piece that it touches, so that case would be 9. So we would get the square root of 108. Now for this problem, I know that I can split this one up, and I'm actually just going to split it up into the things that I knew that I could split it up in already. So I would take, because I can take the square root of 9 and get 3, and I can also split 12 up into 4 and 3, and I know that I can take the square root of 4. And the square root of 3 would be left over. So on the outside here, the square root of 9 is 3, square root of 4 is 2, and I'm left with this square root of 3 left over. So that would be 6 root 3. Another way to think about that is that since I pulled out a 6, just like over here, that means that 36 actually does go into 108. And if you need more help with this factor tree stuff, you can come see me before school and I can run down some problems with you. But that's kind of the idea. Those are the two leg problems that we're looking at, where you're taking the whole hypotenuse and then the piece that it touches, whole hypotenuse or the piece that it touches. For the next one, we're dealing with this altitude here. So I'm going to look at this formula. It's the geometric mean between my two bases. So my altitude is 5. The geometric mean between my base 1, which is x, and my base 2, which is 2. And then to solve this, I need to get rid of that square root, so I'm going to square both sides. Over here I get 25 is equal to 2x. Divide both sides by 2, and I'm just going to leave this as a decimal. I'm going to give it as 12.5. There's x. So this is 12.5. I know I'm going to need that because then this makes this whole hypotenuse 14.5. And y is a leg. So y is the geometric mean between my hypotenuse, again my hypotenuse is 14.5, I just found that, times the piece that it touches, and y touches 2. So this would be the square root of 29. And I actually can't split that up, like I could try to find things that would go into it, but there's really nothing that goes into that, so we'll just leave it as the square root of 29. Okay. Alright, last one here. Again, we have to ask ourselves the question, this should be in x. Is this an altitude or a leg? So I'm going to look at this altitude first. I know that my altitude is the geometric mean between my two bases. Here's base 1, 3. Doesn't matter if you label this base 1 or base 2. And then this base over here, since they all add up to 9, would be 6. So 3 times 6. So that is the square root of 18. I'm going to split that up into 2 and 9. I know I can take the square root of 9. And the square root of 2 I can't take the square root of, so I'll have 3 root 2 for x. For y, that's a leg. So this would be the square root of this entire hypotenuse, which is 9, times the piece that it touches, and y touches 6. So this would be the square root of 54. And to split that up, again, I'm going to use this 9 and 6 because I know I can take the square root of 9, and if I took the square root of 6, I wouldn't get anything. And that's only like broken down into 2 and 3, and neither of those things I can take the square root of. So this would be 3 root 6 left over. That'd be y. Okay, so with that being said, I want to look at the couple on the quiz review. So on this problem, I'm going to redraw these. That way I can label and look at what I'm actually dealing with. It's telling me that FG is 24. It's telling me that DG is 6. And EG is, we don't know, X. So again, this is an altitude, which means the altitude is the geometric mean between my two bases. So 24 is equal to the square root of base 1, which is 6, times base 2, which is 7, or X. And then to solve this, I would square both sides. If you do that, you'll get that the square root of 24 is 576. Square root and this square go away, and I'm left with 6x. And divide both sides by 6, and you'll get 96 is your answer. Alright, for the next one, it tells me that DG is 25. It tells me that EG is 22. And we're trying to find FG. We're trying to find that. So again, we're dealing with an altitude here, which means that we need to take the geometric mean between my two bases. So I'm given base 1 is 22. I'm not given this base, but we can find it because it's 25 minus 22, which is 3. So then this would be the square root of 66. And if I tried to split this up, I would get 6 and 11. Neither of those things I can split up into anything, so we'll just leave it as the square root of 66. For the last one, we're given that FE is 42. We're given that EG is 16. And we're trying to find DE. So we're trying to find the whole hypotenuse. So we have then, since we're dealing with the whole hypotenuse and we have a leg, I'm going to use the leg formula. So its leg is the square root of the whole hypotenuse, which is x. We labeled that, and the piece that it touches, which is 16. And just like number 4, to solve this, we need to square both sides. If we square 42, we get 1764. Square and the x go away, and we're left with 16x underneath the root. We would divide by 16 on both sides, and we'd get 110.25. So the geometric mean ones above are just like this part of that. We just really have to multiply the two numbers and take the square root. So this would be 6 times 36, and then we can take the square root of both of those or split it up or multiply them. This one, I know there is a square root of 36, so I can take the square root of 36, and then I'll just leave that leftover 6 inside my root. For the next one, we would do 15 times 18, square root of that. If we do that, we'll get a really large number. I'm actually going to split these up right now. I can't take the square root of 15 or the square root of 18 and get something, but I know that 18 I can split up into 9 and 2, and 15 I can split up into 5 and 3. And for this one, that means that I can actually take the square root of 9. Everything else is a prime number. So if I do take the square root of 9, I'll get 3, and then left over on the inside I have a 5 times a 3, which is 15, times 2, which is 30. And the last one, if we're going to take the square root to find the geometric mean between these two numbers, we'd have to multiply them. We have a fraction times a whole number, so the way we're going to handle that is turn that into a fraction, so put it over 1. And then we multiply the tops, 49, multiply the bottoms, we get 3. And then split that up into the square root of the top and the square root of the bottom. The square root of the top, square root of 49, we know is 3, and we can't take the square root of 3, so we'll leave that in the denominator. But this is a problem that we already handled today, even in 6.2. So the way we tackle that is we need to rationalize. So we'll multiply by root 3 over root 3. The top we just put together is 7 root 3. The bottom, root 3 times root 3 is 3. This stuff, rationalizing and simplifying radicals, you did in Algebra 1, so this shouldn't be like crazy new, but you may need a refresher. The last ones I just want to go over real quick. Finding the exact value of x. We're either dealing with a 30, 60, 90 or a 45, 45, 90 triangle in these cases. This one is that 30, 60, 90 triangle, so I know that that's my 30 degree. That means that this side length over here is my short leg, and I know that in my 30, 60, 90 triangles, my long leg, which is across my 60 degree, which is what I'm trying to find, x, is equal to root 3 times my short leg, and I know my short leg is 7. So that means that x is 7 root 3. For the next one, I'm given a leg. Both these side lengths are the same, so that means I'm dealing with a 45, 45, 90 triangle. I know that my hypotenuse is equal to root 2 times my leg. My hypotenuse is x in this case. My leg is 8. So I get 8 root 2. And the last one, again, this is the 30, 60, 90 triangle. I know that not only is this true, the long leg is equal to root 3 times my short leg, but my hypotenuse is equal to 2 times my short leg. So my hypotenuse was given as 16. This is my short leg. So that's 2 times my short leg, which is x. Divide both sides by 2, and we get x is equal to 8. And the last one, deciding whether this triangle forms or these side lengths form a right triangle, we really just have to test that in the Pythagorean theorem. So does 13 squared plus 14 squared actually equal 15 squared? And if you find this number, it should be 365, I think, and this will be 225. So no, these do not equal each other, so no, this does not form a right triangle. Okay, I hope this was helpful. I'll be here before school tomorrow, so you can, or be at school before school. So if you have any questions on this quiz review, please stop by to see me. See you then.